Have you ever been there? You know, that moment of pure digital panic. You're trying to check out online, maybe book that really important flight, and boom, the app just freezes up. Or it crashes completely. Or maybe even worse, it just sits there spinning and spinning, waiting for, well, who knows what, because nothing's happening. It's that feeling where you can almost like feel the opportunity slipping away. It's more than just annoying, right? It can really shake your trust, cost money, lose customers. Well, today we're going to dive deep into a really powerful way to stop those nightmares from happening. It's called the circuit breaker pattern. And we'll specifically look at how a tool called Hystrix makes this happen in Spring Boot applications. Think of this as your inside track to understanding how these big, complex apps manage to stay reliable, how they keep you, the user, happy, even when things behind the scenes go totally wrong. So our mission today is to take these pretty sophisticated concepts and make them really clear, really actionable. We want you to walk away feeling like you truly get it, maybe even impressed by how elegant the solution is. All the insights we're discussing, they come from a great summary aimed at beginners, but we're going to really unpack it for you. Let's get started and see how apps can become, well, almost unbreakable. Okay, so to really get the circuit breaker idea, you first have to understand the challenge with modern software. Apps these days, they're rarely islands, are they? They're more like these complex ecosystems, pulling data from databases, talking to payment gateways, maybe getting weather info from somewhere else.
Exactly. They depend on lots of other services.
Right. And the problem isn't if one of those services will have a wobble, it's pretty much when. And traditionally, a small hiccup in one place could bring the whole thing crashing down, a cascading failure.
Mm-hmm.
That's where the circuit breaker pattern comes in. If you need a quick picture, think about the fuse box in your house, or the circuit breaker, rather.
Yeah, the safety switch.
Exactly. If one circuit gets overloaded or faulty, that switch trips, right? It cuts the power to prevent damage, maybe even a fire.
Stops things getting worse.
Precisely. And in the software world, this pattern does something similar. It smartly stops your app from just banging its head against a wall, trying to connect to a service that's clearly failing. It protects your own app and gives that broken service a chance to recover.
And what's really interesting is Hystrix. This library came out of Netflix, actually. They needed extreme resilience, for streaming. Hystrix is like the smart manager implementing the safety switch. It's not just passive.
Okay, so it's actively doing something?
Yeah, it actively watches how well all those external service calls are performing. Every single one. And if it sees too many failures or things getting too slow, Hystrix basically says, okay, enough, and it opens the circuit.
Opens it,
Yeah.
meaning it stops the connection.
Right. It instantly stops any new requests from going to that problem service. But here's the clever bit. Instead of just throwing an error back at the user,
Which is what usually happens.
yeah, instead it automatically switches to a backup plan. Maybe it shows some data it cached earlier or just a default message, something useful. Then, later, when Hystrix senses things are okay again, it intelligently closes the circuit and everything goes back to normal.
Ah, I see. So it's not just stopping the crash, it's actually managing the experience during the outage. That's a key difference. So for you listening, why is understanding this so important? It sounds like it moves beyond just fixing errors after they happen. It's more proactive.
Exactly. It's proactive resilience. The big insight isn't just it stops crashes, though it does that, absolutely. It's that it changes your application's whole approach to failure. It helps it adapt, learn from failure instead of just falling over.
From fragile to anti-fragile, you might say.
That's a great way to put it. So understanding this means your apps can stop those pointless, resource-hogging calls to services that are down. It massively improves the user experience because you're almost always giving some kind of response, even a fallback. And let's be honest, seeing slightly old data is way better than a blank screen or some technical error,
Well,
right?
definitely. Less panic-inducing.
For sure. And it also protects your own system's resources from getting swamped by retries, which in turn makes those really critical apps, think online stores, banking systems, much, much more reliable. And ultimately, it simplifies what used to be incredibly tricky error handling. It lets you build really solid apps without needing, a PhD in distributed systems. It's about designing for graceful failure, not just hoping failures won't happen.
That really does shift the thinking. Okay, so let's pull back the curtain then. How does this sophisticated safety switch actually work under the hood? What's Hystrix doing?
Well, it all starts with monitoring. Hystrix is like a super diligent quality control manager. It watches every single request your app makes to an outside service database, another microservice, some third-party API, whatever. It keeps track of successes, failures, how long things take, building this real-time health check for each service. And all that watching feeds into what we call the 3 circuit states. These define how Hystrix behaves. First, you've got the closed state. That's normal operation. Everything's fine. Requests are flowing through. Hystrix is watching, but not interfering, like a lifeguard on a calm day.
Okay, standard mode.
Right. But then, if Hystrix sees too many problems, maybe, say, half the requests fail over a 10-second window, you can configure this threshold. It flips to the open state.
Trips the breaker.
Exactly. And in the open state, Hystrix intercepts all new requests heading for that service. It blocks them, stops them cold, and immediately redirects them to that fallback plan we talked about. No more banging head against wall.
Got it. Protects the system.
Then, after a set amount of time you configure this too, it gives the troubled service a breather. Hystrix moves to the half-open state.
Half open. Sounds tentative.
It is. It's like testing the waters. Hystrix allows just a couple of requests through to the service, like little scouts. If those succeed, great signal. Service is likely back up. Hystrix closes the circuit, back to normal.
And if they fail?
If they fail, nope, not ready yet. Hystrix immediately snaps back to the open state, keeps the block in place. It's like, you turn off a faulty appliance, wait a bit, then plug it in just for a second to see if it sparks again before you trust it fully.
That's a really smart recovery process.
And the really crucial part of that open state is the fallback. It's not just about stopping requests, it's about what you do instead. When that circuit is open, Hystrix instantly calls your predefined backup code. Like we said, could be cache data, maybe just a default empty list so the page doesn't break, or maybe even routing the request to a completely different backup service if you have one.
So, if the main product database is down, maybe it shows results from a less detailed but available cache.
Precisely. The user can still browse, even if maybe the price is 5 minutes out of date, way better than an error page. And Hystrix also handles timeouts and limits. You set a maximum time for any service call if it takes longer than that. Hystrix considers it a failure, stops your app waiting forever.
Prevents those endless spinners.
Yes. And it can also limit how many requests can go to one service at the same time, like a bulkhead on a ship.
So one slow service doesn't hog all the resources and slow down everything else.
Exactly. Prevents one bad apple spoiling the bunch. Think of it like telling a delivery driver they have exactly 10 minutes to show up. If they don't, you immediately call your backup option instead of waiting around all day.
That makes a lot of sense, especially that half-open state that feels really elegant for recovery. So let's take a concrete example. Say you've got a Spring Boot app. It needs live weather data from an API. If that weather API suddenly dies or gets super slow, Hystrix would notice. Right, you'd trip the circuit, open state, so stop calls to the API. Then, crucially, it would immediately serve up maybe some cached weather data it stored an hour ago, the fallback.
Right, keeps the app functional.
And then, after a pause, it does that half-open thing, sends a quiet test request or two. If they work, circuit closes, back to live data. The user might never even notice there was a problem, beyond perhaps slightly stale data for a moment. That's huge for user experience.
It really is. Minimizing disruption.
Okay, we've covered the what and the how. Let's bring it back home. For you listening, what specific, maybe painful headaches does using circuit breakers with Hystrix actually solve when you're building stuff?
Oh, it tackles some really fundamental problems in distributed systems. Real pain points. First, those catastrophic app crashes we talked about. When an external service like payments just keeps failing, your app can burn through all its resources trying again and again and then just die.
Yeah, seen that happen.
Hystrix stops that. Opens the circuit, serves the fallback, like showing cache payment options, your app stays up. Second, slow performance from unreliable systems. One slow database query or a sluggish API call can make your whole app feel like wading through treacle.
Frustrating for users.
Totally. Hystrix enforces those timeouts, cuts off slow calls quickly, provides a fast fallback, keeps your app feeling responsive, maybe shows cache data instead of that long wait. Third, cascading failures. This is a big one. A failure in one small part, like inventory check, can ripple out and break the whole checkout process in an e-commerce app.
Right, seemingly unrelated things break.
Hystrix prevents that. It isolates the failure. Opens the circuit just for that faulty inventory service. The rest of the app, browsing, adding to cart, keeps working. It contains the problem. Fourth, it drastically cuts down on high maintenance effort. Manually dealing with Errors from external services, debugging, restarting things, tweaking configs, it takes a ton of time, especially if you're newer to this.
Yeah, firefighting constantly.
Hystrix automates so much of that failure detection and handling, the circuit logic, the fallbacks. It reduces that manual burden significantly. And finally, and maybe most importantly for the end user, it fixes poor user experience during failures. Instead of cryptic errors or those dreaded spinners, Hystrix ensures the user gets something. Cache data, a try again later message. Anything is better than a broken page. It keeps users happier and less likely to leave.
Okay, this sounds incredibly valuable, powerful stuff. But you also said it's surprisingly beginner-friendly in Spring Boot. That almost sounds too good to be true. How easy is it to actually set this up?
It really is much more straightforward than you might expect, mostly because Spring Boot and Spring Cloud handle a lot of the heavy lifting. First step, add Hystrix to your project. Usually that just means adding one line to your project's build file, like a pom.xml if you use Maven. You add the Spring Cloud Netflix Hystrix starter dependency.
Okay, so just telling the project to include the Hystrix library.
Yep, it's like plugging in a pre-made safety module. Second, enable Hystrix. This is often just one annotation at Enable Circuit Breaker that you put on your main application configuration class. It's like flipping the main power switch for circuit breaking in your app.
One line of code.
Pretty much. Then, you set up circuit breakers for specific tasks. This is where it gets slightly more involved, but still manageable. For any method in your code that calls an external service you want to protect.
Like the call to the weather API.
Exactly. You add another annotation to that method, at Hystrix command, and in that annotation, you tell Hystrix the rules, like, this call shouldn't take longer than 2 seconds. Or, crucially, if this fails, call this other method instead.
Ah, so you pointed to the backup plan.
Precisely. Which leads to the next step, configure fallbacks. You actually write the other method, the fallback method. This is just regular code where you decide what happens when the main call fails or the circuit is open. Return cache data, return a default value, log an error, and return a nice message. Your choice.
So you define the contingency.
You define the contingency. And then often you'll want to use caching for those fallbacks. If your fallback is showing cache data, you'll probably integrate a proper caching tool like Redis or maybe EHCache to make sure that data is fast and readily available.
Wow, okay. Using annotations like at Hystrix command does sound much simpler than manually wiring up all that logic. So it really does empower developers, even newer ones, to build apps that are inherently more reliable and user-friendly from the start. That must be a huge confidence booster, knowing your app has this built-in resilience.
It absolutely is. It automates handling for those tricky, unpredictable external failures. Prepares your app for the real world.
Yeah.
But it's not magic. There are a few important things to watch out for.
Okay. Caveats. Good to know.
First, your fallbacks need to be meaningful. Just returning null or a generic error message might prevent a crash, but it doesn't help the user much. The fallback should offer some real value, even if limited.
Right. Make the backup plan actually useful.
Second, avoid overdoing it. Don't just slap at Hystrix command on every single method in your code base. That adds overhead and complexity. Start with the most critical external calls, payments, authentication, core beta sources. Be strategic.
Focus on the high-risk areas.
Exactly. And finally, tune your configuration carefully. Those thresholds for opening the circuit, the timeout values, how long it waits before trying again in the half-open state. These need to be set appropriately for your specific services. If you set timeouts too short, you might open circuits unnecessarily. Too long, and you might impact performance. It requires a bit of thought and maybe some monitoring.
Excellent point. Right, so we've covered a lot of ground there. A real deep dive into the circuit breaker pattern, Hystrix, and how it works in Spring Boot. You should now have a much clearer picture of how you can build applications that are, well, tougher. Apps that handle failure gracefully, keep users happier, and hopefully mean fewer late-night emergency calls for developers, all even when the systems they depend on get a bit flaky. But before we sign off, here's something to maybe chew on. If this whole idea, isolating failures, having a backup plan ready, is so fundamental for making complex software stable, where else could that thinking apply? Think about other complex systems or challenges, maybe in your work, maybe even in life. Where could thinking like a circuit breaker, identifying potential failure points, setting up safety mechanisms, having a fallback ready transform potential chaos into something more resilient, more manageable? Where else could this pattern apply, beyond just lines of code?